Define if we take the lines away. The most interesting star, I think, is the star that could be shocking in our sky. This star is Betelgeuse, a red giant. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous and very unstable. It's about to explode. In recent weeks, the James Webb Space Telescope has made astounding discoveries, but one recent revelation stands out, sending shockwaves throughout the scientific community. Astronomers recently directed the James Webb Telescope to Betelgeuse, a prominent star in the night sky. The telescope detected an unusual sign, immediately interpreted and analyzed by scientists. What they found caused huge concerns as it suggested the potential for a massive supernova explosion. Particularly, Brian Cox, a renowned British physicist, believes that the Betelgeuse Supernova is imminent and could occur at any moment. This development has raised many questions about the implications for Earth and the severity of the effects resulting from the unprecedented supernova event. Join us today in this exploration as we delve into the James Webb Telescope's unsettling announcement regarding Betelgeuse's impending explosion and what Brian Cox has to say about it. Betelgeuse is classified as a supernova due to its extraordinary size and power, presenting a celestial marvel that baffles scientists with its irregular pulsations and high unpredictability. A star,
Betelgeuse, the 10th brightest star in the night sky, is a red supergiant about 700 times the size.
The enormity of Betelgeuse sets it apart, being 700 times the size of the Sun and 15 times more massive. The Betelgeuse supernova continues to awe researchers with its inexplicable extremes. In a recent research study, scientists used the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, LIGO, to capture celestial phenomena in space. Scientists were taken aback after reviewing the data, which revealed a light wave emanating from the Orion constellation, positioned at the left shoulder of Orion. Betelgeuse falls into the category of semi-regular variable star, meaning it dims irregularly. This dimming allows us to gauge its distance from Earth, approximately 475 to 642 light-years away. The Betelgeuse supernova experiences dimming roughly every 430 days, with dark spots emerging on its surface during each 6-year cycle, analogous to dark spots on our Sun. In February 2021, the supergiant underwent a particularly dim cycle. The James Webb Space Telescope and the Hubble Space Telescope provided detailed images exposing distinctive patterns of gases and dust clouds on Betelgeuse's surface. These observations enable scientists to construct accurate models of the star's behavior, providing insights into its future evolution. ALMA, an advanced observatory in Chile, delivered ultra-high-resolution images of Betelgeuse's surface, unveiling significant insights into the structure and behavioral patterns of this red supergiant. Among the remarkable discoveries facilitated by ALMA's technology is the identification of an expansive gas plume extending from the star's surface. This plume, believed to be induced by Betelgeuse's pulsations, offers a potential explanation for the star's distinctive behavior and ongoing transformations. Betelgeuse's pulsations, triggered by convection, involve the upward movement of hot gases and the downward movement of cooler gases. This cyclical motion generates waves that traverse Betelgeuse's atmosphere, causing it to expand and contract. Betelgeuse's surface features dark spots, known as star spots or magnetic spots, corresponding to regions where the star's magnetic field is most potent. These magnetic fields create cooler areas compared to the surrounding gas, inhibiting the flow of hot gas from the star's interior to its surface. Believed to be several thousand times stronger than the Sun's magnetic field, Betelgeuse's magnetic field traps gases in loops, resulting in zones of intense magnetic activities visible as dark spots in the images. Star spots, a common occurrence, are not exclusive to Betelgeuse. Many stars, including our own Sun, exhibit these features. The dark spots on Betelgeuse's surface are believed to be significantly larger than Earth, covering up to 20% of the star's surface. These star spots directly impact a star's brightness, causing fluctuations over time. The more star spots present, the dimmer the star becomes. The recent gravitational wave readings from Betelgeuse have stirred concern among astronomers. The discussed dimming is a common behavior in stars approaching the end of their lifespan. The challenge lies in the fact that stars of Betelgeuse's magnitude don't fade away quietly, they go out with a bang. Supergiants exit dramatically with a supernova explosion befitting their size, brilliance, and magnificence. Scientists are now contemplating the likelihood of Betelgeuse undergoing such a supernova explosion. If it does, researchers hope that it happens soon, as such an event would offer invaluable insights into the cosmos. If Betelgeuse were to end in a spectacular ball of flaming gases, the effects of the supernova would be observable from Earth, even in the brightness of day. The signs and data emanating from Betelgeuse affirm that it's only a matter of time before this red supergiant bids farewell to the cosmos. However, pinpointing the exact time frame for this cosmic exit remains undetermined. Recent data gathered by the James Webb Space Telescope and the Hubble Space Telescope indicates that just a few years ago, the red semi-regular variable star underwent a significant eruption, losing a substantial portion of its visible surface. This explosion has triggered a considerable surface mass ejection from Betelgeuse, raising questions about whether it is on the verge of a complete explosion. The magnitude of this massive ejection, with substantial dust clouds, is an unprecedented occurrence for scientists. It deviates from the typical behavior of both young and dying stars. While our soon experiences minor outer atmosphere losses in coronal mass ejections, they pale in comparison to the intensity of Betelgeuse's ejection. Observations from the James Webb Space Telescope reveal that the red giant is gradually recovering from the substantial ejection. Despite ongoing scrutiny from scientists, the recent phenomena surrounding Betelgeuse remain a source of puzzlement. The star's recent activities provide an invaluable learning curve for scientists as they strive to unravel the complexities and mysteries of this celestial giant. Observations from the James Webb Space Telescope shed light on the process of how red stars shed mass as they approach the end of their life cycle. Scientists have uncovered that these stars lose mass as their nuclear fusion furnaces begin.
Betelgeuse, the 10th brightest star in the night sky, is a red supergiant about 700 times the size of the Sun.
Betelgeuse indicates a likely prelude to the demise of this colossal red star. This development has stirred heightened concern among scientists and astronomers alike, who are diligently working to obtain a more definitive understanding of these occurrences. The huge ejection of mass by Betelgeuse is believed to have originated from the convective plume that spans over 1 million miles across its surface area. Emerging from the star's depths, this plume generated powerful pulses and shocks, leading to the expulsion of a portion of the star's photosphere, creating an expansive, cool surface area beneath. The dust raised by this mass ejection has dispersed into space, cooling and forming a dust cloud that obstructed Betelgeuse's light from reaching Earth. This obstruction resulted in a conspicuous dimming of Betelgeuse in 2019, lasting for several months. The dimming was so pronounced that even amateur astronomers lacking sophisticated instruments observed the marked reduction in the star's brilliance. For over 2 centuries, scientists and astronomers have meticulously observed Betelgeuse's rhythms and movements, documenting the noticeable disruptions that underscore the profound impact of this blowout of the star's photosphere. Analysis from the Tres and Hubble spectra suggest that while the outer layer may return to normal soon, the star's surface remains in a precarious state, awaiting the completion of the photosphere rebuilding process. While our Sun has experienced coronal mass ejections, the stark difference in magnitude between the Sun's ejections and the recent surface mass ejections from Betelgeuse emphasizes that these events cannot be equated. Betelgeuse's expansive growth over millennia is evident, and if it occupied the Sun's current position in the cosmos, its outer orbit would extend beyond Jupiter's orbit. The red hue of Betelgeuse indicates that the star has reached the stage where stellar bodies deplete their hydrogen reserves, leading to the collapse of the core and the puffing out of the outer layers. In contrast, our Sun is still relatively young and has a long journey ahead before reaching this mature stage. Scientists estimate that it will take another 5 billion years for the Sun to reach such maturity. When it does, projections suggest that its radius will expand to proportions reaching Mars's orbit. Following the significant dimming of Betelgeuse in late 2019, scientists closely scrutinized the star's altered behavioral pattern. Although the supergiant star regained its brilliance within months, scientists were intrigued by the initial cause of the dimming. The debate among researchers about Betelgeuse's potential supernova is ongoing. Some speculate that its time is nearing its end, while others argue that the red giant may have tens of thousands of years left. The most recent supernova observed in our Milky Way galaxy was in 1604. Although there could have been subsequent nearby supernovas hidden by atmospheric gas and dust, instances like the Crab Nebula, originating from a supernova in 1054, serve as remnants of explosive events. The 1987 supernova in the Large Magellanic Cloud and the Kepler supernova are among the more recent observable occurrences in galaxies beyond our Milky Way, highlighting the dynamic nature of the universe. In simpler terms, witnessing a star explosion in our galaxy is a rare occurrence. Astronomers estimate that our galaxy experiences an average of 1 to 3 supernovae every century. Today's astronomers are better equipped for such events compared to astronomers of Kepler's time. Modern telescopes can capture visible light, providing insights into how supernovae would appear if observed nearby. Infrared telescopes, like the James Webb Space Telescope, extend beyond visible light, penetrating gas and dust to reveal celestial objects not visible with conventional telescopes. Apart from light observation, scientists can also detect neutrinos and subatomic particles emitted by supernova using specialized detectors. Moreover, detectors for gravitational waves, minor vibrations in space and time, offer another dimension to supernova study. Supernovae come in two main types. Type 1 involves the white dwarf star undergoing a runaway nuclear reaction, while Type 2, or core collapse supernova, results from a star collapsing under gravity after running out of nuclear fuel. Type 2 supernova are particularly intriguing as they emit not only light, but also a significant amount of neutrinos. Neutrino emission may precede the explosion, allowing detectors to pick up signals hours or even days before the visible explosion occurs. Betelgeuse has experienced recent brightness fluctuations, leading to speculation about a potential supernova explosion. However, recent research suggests that the dimming may be attributed to dust clouds or sunspot activity on the star's surface. Theoretically, life on Earth could be endangered by a close supernova, but that explosion would need to be in close proximity. Fortunately, no imminent supernova candidates pose a threat. If you like this video, then subscribe.